Hi everyone. Thanks for coming to this session. Today I'm going to talk about tools and teams for 20 billion page view per month. Now, just a little disclaimer, this is by no means a blueprint. This is a return of experience of what has worked for us in the past, what is working for us now, and take this with a grain of salt, of course, and your mileage may vary. So let's start with who I am. My name is Damien. I've been working in tech for the last 12 years now. I've been managing development teams, and now I focus more on the infrastructure side of things. I'm a director of engineering. You can find me on Twitter. And I currently work for a company that is called Teads.tv. Just a few words about Teads. We are a global media platform, which means that we help content publishers, such as newspapers all over the world, monetize the content that they produce, and we help advertisers spread the word that they want to spread on the planet. We're a French company. We were created about 7 years ago. We work in the ad tech business, and we focus on clean advertising. We believe that for the internet to remain free and open, advertising is necessary, but it doesn't have to suck. So we work hard in order to make advertising suck less and be as clean as possible, as good as possible. And we do this at scale. Our cumulative reach every month is about 1.2 different billion people. So a lot of the internet population. And this is where the 20 billion page view per month come from. In order to give some context, I'll just a few words about the infra that we are running at Teads. It starts to be a pretty large infra. At any given moment, we will have about 1,600 virtual machines that run. We will handle about 10 million requests per minute on all our different HTTP endpoints. And we will egress about 5 petabytes of dynamic traffic every month. That is mostly HTTP call. This is not video. This is not image data. All right. So a few weeks ago, as I was doing some reporting, some internal reporting, I actually looked at that number, those 20 billion page views, which actually in August went to 24 billion. And I tried to take a step back and think about what are the tools, what are the decisions that we made early on in this company, 7 years ago maybe, that allowed us to scale year after year with more than a 50% growth. And I truly believe that one of the core decisions that we made is that we're a cloud-native company. Now, in 2018, this is like, it's a no-brainer to use the cloud. Every startup that will start today will use the cloud at some point. In 2011, back when Teads started, this was a strong choice. This was something that was not normal. Most of the companies that started at this time were using physical infrastructure. And I truly believe that this core decision allowed us to scale. Because when you go from 1 billion page view to 5 billion page view, if you're running on physical infrastructure, it's going to be really hard to keep up with the pace at which your traffic is coming up. And also, this is the decision that gives us our velocity, meaning that most of our dev teams do not have to worry about, is there a spot for me on the infra to run this code? With the cloud, we have access to virtually infinite amount of resources. And this is something that we truly lean on as we scale, as we grow, as we continue to grow, because we continue to have about between 30 and 50% year-on-year growth on the business and on the traffic side. And it's a decision that we did challenge. I think 4 years ago, we merged with another company that was doing ad tech business as well. But they came in with a physical infrastructure. And as in any merger, everyone wants to push their solution, right? So we did a POC, we did a proof of concept. What if we took our cloud infra and run it on physical infra? And it took us about a year and a half to run this POC. We went as far as to run a large Mesos DCOS. And it started working, but we had lost our focus. We went from being able to deploy very quickly to having to support 2 different systems for more than a year, not knowing on which one we will end up. And so we took a very hard decision to just stop that physical infra and to move everything to the cloud. Now, this comes with a hefty price. I looked at our first bill this morning, and the first bill ever for Teads in the cloud was $52. I think last month we billed more than a few $100,000. So the cloud is very expensive. You probably will find it less expensive at our scale and with our specific business to run on physical infra, specifically for the egress part, because we send a lot of data out to the internet, and that is very costly in the cloud. It is not in the physical infra. It's less costly. But it's a price we are willing to pay to keep up with velocity and scalability. Now, that being said, we are huge cloud monogamists. We believe that multi-cloud is a trap, indeed. And why we believe so is that it is hard enough to learn one cloud, to master one platform, to understand the deep way of working of the platform that we chose, which was AWS 7 years ago. And we have a pretty strong knowledge. We have a pretty good relationship, technical relationship, commercial relationship with AWS. So we find it that starting a multi-cloud strategy will hurt us in the way that we will need to learn another platform. And it's not impossible, but it's not as easy as it seems. Granted, starting a few instances in any cloud is very simple. It's a few clicks away. But when you want to run at scale with high availability in mind, it's a lot harder. Again, because we do it this way at Teads, we challenged this decision, I think 2 years ago. 2 years ago, we decided to serve traffic from a third region. We were serving traffic from Europe and the US, and we wanted to serve traffic from Asia to be closer to our customers. And we decided what better time for us to start a multi-cloud strategy than to open a third region on a different cloud. It will give us like cheap PRA and etc. And it took about 2 weeks, I think, to write the pros and cons, have them run over, think about it, and decide not to do it. And we decided not to do it because we wanted to keep focus. Because in the end, running on different clouds does not really remove the vendor lock-in, because you're locked into 2 vendors instead of 1. Does not really give a lot more safety than running on different regions in the world on the same cloud provider. At least that's what we believe. So we decided against it. And again, on that monogamy, we allow a little cheating, just a bit. And we allow cheating for competitive advantage products. GCP today, the Google Cloud Platform, has a product that has, in our opinion, no equivalent in the product catalog from AWS. Our product is BigQuery. It's a big database that allows you to run SQL queries with a constrained amount of time on very, very large set of data. And we are using BigQuery extensively. So one could say that we are using multi-cloud. The way we see it, we are using one cloud and then one service. So we use BigQuery as a SaaS software, which is, we use a lot of SaaS software for the same reasons, mainly for focus. We believe that, I want my engineers, my team, to work on things that have value for the company. Working on restoring a Git server, in my opinion, has no value for the company. It has value for the developers, of course, but this value can be outsourced. Working on maintaining a log collection stack, while very interesting, is not something that I want to spend my time on. So for all these use cases, we will go the SaaS way. For the database, it's just about the same. Instead of hosting it ourselves, we will outsource it. And some of the monitoring also, we will use SAAS services, mostly because so, for example, for log collection, it's very easy, it's very straightforward to start up an ELK stack, Elasticsearch, Logstash, and Kibana, to have your log collection and your ability to do monitoring on it. What's harder is make that ELK stack scale and become highly available. So some of the monitoring we outsource, some of it we don't. And we enter that buy versus build paradigm, which I believe, as software engineers, we are strongly biased into not buy versus build, but build versus buy. Our core job as engineers is to solve problem and build stuff. So why buy it? Why should we buy it? We know how to do it. It's not that hard. It shouldn't be that hard. And again, starting up a monitoring stack for a few hundred instances is indeed something that is very straightforward. Having it scale, having it like always on, always highly available, is a challenge that for some part of our infrastructure we don't want to go into. Now, we do build some of our monitoring, and basically we have a segregation between the services that we write. So all the code that we write, we will monitor ourselves. All our applications send data into our Graphite server. So for those of you who don't know, Graphite is a time series database that was built. It's a great piece of software, very stable, highly, very, very high throughput. And it was built about 10 to 12 years ago. And it was not built with distributed, with horizontal scaling at mind. It was built at a time where horizontal scaling basically did not exist. And we are running a large Graphite, we were running a large Graphite instance, and we were hitting about 50,000 data points per second ingesting in that box. And to our opinion, we reached the maximum of what we accepted as vertical scaling. So we started a project to go from vertical to horizontal scaling. And it's doable. It's doable with Graphite. It's doable with other implementation of Graphite, such as Big Graphite, for example, which relies on Cassandra for the storage part. And you get all the properties of distribution that Cassandra has built in. And to do an echo with the buy versus build, we started analyzing, should we do it or should we buy it? And we got some quotes, and the quotes were very expensive, and we discussed internally, and I asked my team for a rough estimate. We don't do much estimate at Teads, but we want to have a point in time where we can just stop and look at what we've done and see if we're on the right path or not. So I asked for a very rough estimate, and that estimate came back. It was 4 to 6 weeks. So from the engineer's point of view, it will take 4 to 6 weeks to build versus the buy, which was very expensive. So I said, let's go for it. Let's go for it. And we went in April this year, and we released the Go Graphite cluster, so the iteration, last week. So if you think about it, it may have been cheaper to just buy it. Even though, in the long term, in the long run, you will have to buy it every month. You will have to continue paying every month. Even though it's a long-term buy, I believe that maybe it was cheaper. It's not, but it's not a big deal. We did it. We're happy we did it, and I hope we will not find a lot of stones on that road. So for everything else, so for systems monitoring, for data stores monitoring, we will use external providers, such as Datadog, for example, or Sumologic for the logs. And it's very important that once you have a big monitoring stack in place, your developers will love it. They will love it, and you can use this as a cornerstone to start full automation of all your stack, all your platform. And this is something that we've been relying on for a long time also. As anyone, we have a traffic pattern that is a sinusoid, and we use extensively the elasticity of the cloud. When there's a lot of traffic, we have a lot of instances. When there's low traffic, we don't have that many instances. And again, when Teads started, the automation was not built in from the start. Teads started with a couple of developers that grew out to 5 developers. Those guys were writing more and more code, and then we were 20 developers. And then we reached a point where running tests and build locally on your machine was not something that you could do anymore. It was too time-consuming. You will spend too much time doing so. So we automated with a continuous integration system, which, again, is pretty standard today. And one of the things that we thought about when we did that was to have our CI be defined as code. So we have a large Jenkins cluster that runs about 700 to 800 jobs. And all those jobs are not defined by clicking in the console, by creating them manually on the UI. They're all defined as code. We did that by thinking, if we let everyone just configure their job as they want, and we have a crash, we have a problem, we need to restore that Jenkins master. How will we do that? Backup is an option, but it's not a very fast option. And last year, we had a very, very high, very important crash in our Jenkins master, and we had to rebuild it from scratch. And it took us about between 30 and 45 minutes to have it back up, all ready to work, ready to do the job. And for the CI system, I was reading a very interesting article last week that was basically saying that the importance is not in the system that you use. The importance is in your pipelines. And I truly believe so. We love Jenkins because it does the job. We hate the Jenkins UI, just as anyone. But in the end, it's not that important. It's not very important whether you choose Jenkins, CI, Travis, whatever, you name it, Go CI. What's important is what you do with it in the pipelines. So we just stick with Jenkins. Eventually they will do the UI someday. I hope so. And now CI, what it does is it builds containers. Now again, 2018, containers everywhere, right? It's normal. Everybody uses containers. We started using Docker, I think, in 2014. So about a year after it was released. And our main reason for using Docker at this time, and it's still true today, is to have one unique package, one unique immutable artifact that you will build, and you will make it move from dev to test to production. And we basically use Docker as a packaging tool. And it does suit our needs. We don't use an orchestrator in production. We don't use Kubernetes. This is probably something that we will look into next year for our low traffic part, for the low traffic part of our infrastructure. But for the high traffic, we learn how to scale our platform by running one container on one host. And it's not that easy to learn how to scale your platform, to learn what key metrics you have to watch, what key metrics you have to act upon. So we don't really want to fix a problem that we don't have. And in the end, we could save a few $1,000s probably by doing so. But the time it will take for us to learn that new pattern of scaling, the risk that we will put our production into is not something that we believe is worth for. So mainly we use Docker as a packaging tool. And Docker also allows us, and it has allowed us for a long time, to lift all our platform onto just one box and basically have an end-to-end testing environment available. And we use AWS Spot instances for that. You can spin up very, very large instances for a very short period of time for barely no cost. And then all the containers that we produce are run as in a stateless way. They do not store state. We don't have long-running instances for all the code that we produce. And if you're familiar with the cattle versus pet paradigm, which is something like, if you're using the cloud, you should treat your servers as cattle. So if it dies, it's not a problem. You should not name them, etc. And we use both. We have cattle and we have pets. and I believe farmers do as well. But what we will do is that all the code that we produce, all the stateless services, we will consider as cattle. We will run on instances that have a very, very short lifetime. Maybe they will have less than 24-hour lifetime, because when we deploy, we rolled instances. And for those instances, we won't take care of them. We won't name them. We basically don't care. They die, they respawn. It's not a problem. Now, for all the state part of our infrastructure, of our platform, all the state is stored into data stores. Data stores such as Cassandra, such as Kafka, MySQL, Redis. For all these parts of the infrastructure, we will treat them as pets. We will cherish them. We will name them. We will run security patches on them. We will apply things to it, provision them, watch the logs, which we don't on the cattle part. And for this part of our infra, we use Chef, which is a provisioning system. And now, interestingly enough, so I was talking about the merger earlier. So that merger brought the physical infrastructure, which we didn't keep, and the Chef mechanism, which we did keep. So every merger has its up and downs, but you will always find bits that you can keep and bits that you don't want to keep. They had a lot of knowledge on Chef. A lot of the code was already written. It was great to use, so we decided to keep it because it made a lot of sense. And the last tool that we use extensively is industrialization. So our journey with Terraform, so Terraform is a framework that allows you to write infra code instead of creating infrastructure, and you run the code through the tool, and the tool creates your infra. Our journey started about 2 years ago when we decided to open that third region. So again, we were serving traffic from Europe, from US, and we wanted to serve traffic in Asia. And the US region had been copied from the European region, basically by having the console, the European console on the right side of the screen, the US console on the left side, and trying to, make it match. Needless to say, we had some typos. Needless to say, we had some errors. We had some things that were consuming a lot of our time, just because because humans make errors, right? So for the third region, we decided against that, and we decided to introduce Terraform and start from scratch a new region, fully Terraform. Now, one of the very interesting parts that comes with it is that instead of needing to keep in your mind a very, very large mental map of which services communicate with which services, what is deployed here, what exists over there, you can now just open the book. You open the Terraform book, and you just read through it. You read it. Okay, yeah, this service listens on port 9045. Okay, I know that. It's written. I don't have to keep a mental map of this. I don't have to keep a mental map of the services communicate there. It's very interesting. It's one of the things that you don't see at first when you start Terraform, but it really, really does have a value there. Your infrastructure becomes reproducible. We now have 3 regions. Next year, we plan on going to 6 regions. This will have would have consumed a lot of time, a lot of engineering time to do next year. It's going to be quite easy because we will be using Terraform, and it's built in for that. And the final thing that was really interesting about it is that it just broke the barrier between devs and ops. What we will do is we will tell devs, okay, so you need a new S3 bucket, just do a pull request in the Terraform repository. Please do. And we will review it, the infra team will review it, will apply it, will create the bucket. But please do, create your own infra. We don't have to be the keeper of the flame. You can create your infra. And yesterday I checked, and that Terraform repository has 57 different contributors. And we are about 100 engineers at Teads. So it means that more than half of all the devs have created at some point some kind of infra for their projects. And this is something I did not truly expect when we started. We started this for the Infra team, but it spread around, and it broke that dev and ops barrier. it's time to talk a bit about the teams, how we are structured, how we were. And now, like any company, Teads started with like a bunch of developers, 2, 3, 5, pretty much doing front, back, DevOps, IT, everything, sec, everything. And then as it grew, the model that it grew into was the component model. So we had basically team back and team front. And team back and team front did not communicate much other than with HTTP requests, right? So adding a new field to a web form was a pain. Where do you start? Do you start on the UI? Do you start on the backend API? How would you do that? And eventually we entered that kind of deadlock mode where it was really hard to have just anything going on because the tickets will fly from one team to another. And so we introduced feature teams. And now I know everyone is doing the Spotify model, but you're not Spotify, etc. And we did not base this solely on the Spotify model. This is not something that we looked at. What we looked at is from a business perspective. We have different areas in our business, that have different constraints and criteria, and we try to organize around this. And one of the challenges that we had is that we wanted those people to be geographically co-located. And we have 3 code-producing offices. So we have like 25 offices in the world, and we have 3 code-producing offices. We have 2 in France, 1 in Paris, 1 in Montpellier down south, and 1 in Bucharest, Romania. And so one of the constraints that we had was to build feature teams in each office that made sense from a business point of view. And it has worked pretty well. Because we matched that with that very, very vague notion of the full-stack developer, I don't much like that term because I don't believe it's accurate. I believe that nobody is really full-stack. But what we mean by that is that we will try to hire T-shaped profiles. So people that have a deep core competency into one subject, but that have a large surface of knowledge on many, many different subjects. And this will allow the feature teams to take a feature from start to finish. Because even though the guy that is doing the feature is a real good Scala developer, he also can do some TypeScript. He also can do some Terraform. It's not a big deal. And we will hire people that have this NV, that have this kind of knowledge, this kind of T-shaped profiles. And we make feature teams responsible for their run. Which means that my team, the infrastructure team, does not intervene whenever there's an outage. If the outage concerns only a feature team, it's the feature team's problem. We will help if they need it. We will provide logs. We will provide information. We will be there as a support team, but it's their responsibility in the end. And like I said, with Terraform, feature teams do create their needed infrastructure. Now, the Infra Team. The Infra Team does not really fit the feature team model. When I joined Teads about 2 years ago, there were 3 people, I think, including me, in the Infra Team. Now, 3 people for that large infra is quite of a challenge, so we had to scale up the team. And one of the things that we tried while scaling up is finding a motto, finding a mission for that team. And the mission we came up with is to provide developers with needed tools to push their code to production as safely as possible. So we are on a mission. We are a support team. We are here to support feature teams in the work that they are doing. And we do so by providing them with tools to CI, tools to deploy, tools to store data, tools to abstract state from their applications. We added the challenge of being geographically distributed because I wanted to have one infrastructure person, at least one, into each code-producing office to ease the physical communication. So I have people in Paris, in Montpellier, and in Bucharest. And while scaling the team, we try to find people from diverse backgrounds. We try to mix in the same team developers, people that had more sysadmin background, people that were distributed system experts, and we try to make that into one team that works to support all the feature teams. And since we are distributed, we've had to come up with something to communicate inside the team, but also to help the communication between the outside and the team. And we try to move all the conversation, all the physical conversation, we try to move it to Slack, because it's a tool that we use a lot. And we have a public Slack channel for the infra, and every day, someone is assigned to be the first responder on that channel. Meaning that every day, every dev that has a question comes up to the channel and will get an acknowledgement in like less than 5 minutes, and will get an answer as quickly as possible. This had two features. It helped developers and infra guys speak together. It helped reduce the gap that exists somehow between those two populations. But also, it helps newcomers understand all the system, all the platform. Because when you join a team with such a large infra, it's very hard to just read documentation and understand what's going on. So if you're responsible for getting a question and answering it, then at that time, you don't know the answer, and you will ask on our private channel, oh, please guys, help me. And we will help him. We will help him in a private way, so that what is visible is that this person has the knowledge. And this builds trust between devs and ops. And it's very important to build that trust, to have a very good working environment, in my opinion. Now, unfortunately, because all the code producing offices at Teads are in Europe, we cannot use this to do a follow-the-sun on-call principle, which is if you have engineers in the US, in Europe, and in Asia, basically you get a 24/7 on-call team just by having contracts on different sides of the planet. So we had to think about how we handle outages during the night, how we handle outages during the weekends. And again, like any startup, in the beginning, the on-call team was very informal. I used to be the CTO and the CTO only. And when he couldn't not sleep anymore, we had to have senior engineers jump in, like the 2 or 3 first people to build the platform. They knew everything. They knew the whole platform, so it was easy for them to join the on-call team. But as we grew, more and more code was added, more and more systems were added. And eventually we outgrew the capacity of even those senior engineers that were there from the start. So we had to rethink the whole process. And the way we tried to rethink it, at first we started by going into a meeting room and say, okay, we're going to document the whole system. Yeah. So that worked. About 6 weeks after that, we had, 2 pages of documentation. Nobody was really into it. Nobody wanted to do it. It's very hard to document up front. So we decided to shift the paradigm and to recruit internally volunteers for a large on-call team. So we set the limit at 12 person. And from the get-go, we decided that nobody was to be on call alone. But we did not want to have level 1 support, and then if you don't understand what's going on, let's call level 2, and then level 3. We have no escalation procedure. We wake up 2 different persons at the same time. We use PagerDuty to do this. And by doing so, we provide our on-call engineers with someone else with which they can exchange ideas. It's quite scary at 3:30 a.m. to have to reboot a Kafka cluster. You don't want to be alone in taking this decision. And if you have someone else that you can run your ideas with it reduces the amount of stress that you feel when that alarm wakes you up at 3 a.m. And I actually experienced it a few months ago, and it was just great to just have a human being to speak to at 3 a.m. and discuss options and how are we going to do this, and what's the business impact, what's the criticality of it. So this is how we try to think about building that team. And so 12 people, 2 people per shift means 1 shift out of 6 weeks, which seems acceptable. We've been using this for 12 months now, and people are not too run out, they are not too burnt. It feels like a good sweet spot for us. And the last thing that we told those people was that, okay, we don't have perfect documentation. All our system is not documented. We have rough knowledge, global rough knowledge of the platform. Guys, you're engineers. You will figure it out. We trust you to figure it out, the problem, and find the solution. And it will take the time it will take. And it's not a problem. We understand that we don't have all the documentation. But you guys are smart. You will find a solution. And this is what we told them, and this is what we tell them continuously. And it's been working quite great so far. And as it's been working, we also build that documentation. Obviously, each incident, each outage, leads to a postmortem. And during that postmortem, we will create and enrich the documentation on different alerts, different alarms. And this is, yeah. So we continuously build those playbooks, which allow newcomers to just reduce their stress level once more. All right, we're reaching the end of the talk. So the takeaways, in my opinion, like everything we do, we try to be pragmatic. It's not that easy in a world where we want to try just about any new tech that comes out, just about any new framework that comes out, because it's fun and because it's more fun to go greenfield than to build on something that is existing, obviously. But we try to be pragmatic in all the decisions that we make. We do challenge the status quo from time to time, as we did with AWS, like cloud monogamy, as we did with physical infra. And I think it's important because the decision that you took a few years ago or a few months ago, maybe in the context of today, is not relevant anymore. I'll take an example. The Terraform structure that we adopted was very fine when we adopted it. Now, Terraform has moved a lot since then and has allowed for a much nicer code structure. Now, we are thinking about rechallenging the structure that we chose 2 years ago to make it more modern for 2019 in order not to build on technical debt. So, in that same idea, we need to act fast because velocity is key in our business. We are competing with a lot of ad tech companies that have very high velocity. We have to be that fast. We need to experiment and we need to iterate. Let's start with something that is maybe not perfect, but it works, and then iterate until it is perfect. And in the end, also, help people take responsibilities. This is the single game changer for Teads. This has been the single game changer for Teads. Basically, we empowered people into saying, okay, this is my code, I'm responsible for it. I'm responsible for the run of it. I understand the different, what this means. So those are the takeaways that I give you from this talk. Oh, yeah, one more thing. Yeah, we're hiring, obviously. We have offices, like I said, in Paris, Bucharest, and Montpellier, and we have many, many different positions open. So don't hesitate to talk to me after that. And do you guys have any questions? Sure. Yes. Oh, yes. So the question is, are we using Docker in production? And yes, we are using Docker in production. Basically, what we do is we build an artifact, either from a pull request or from master branch, and then that artifact gets tested on the CI system. That Docker image gets tested on the CI system, and then goes to production. What I meant by we are using it as a packaging tool is that we use the one host, one container paradigm. So one container will only run on one host. We don't have many containers discussing it with each other on the same host.
All right. One more question. Yeah. So did you notice any performance issues when you moved to Docker in production?
We did not notice a lot of performance issue. We had our fair share of bugs. Docker is not well known for its upwards compatibility standards, so we've hit just about any bugs of the Docker platform. But regarding performance, we believe that the trade-off between that small performance loss and the fact that we have the capacity of running the same exact artifact into different environments is ROI positive for Docker. So we are willing to take that very small hit, which we didn't really measure, but we are willing to take it anyways in order to continue with the system.
All right, one more question. So you said you build from GitHub or repository.
Yes.
But what if when you test in QA, do you build again before you go to production or use an image?
So basically, we use a GitHub workflow. So we will build an image on the branch, and we will test this, and then that image will get that code. I'm sorry, will get merged on master, and at that time we will rerun the test and build a master image, because at some point you need to integrate with other people's work. But we will rerun the test on the master image. Yes. You're welcome. Any other questions? Yeah. Right. So the question is, how do you manage configurations and secrets, like API tokens, for example? So if it's a bit technical, but basically each release, each new code deploy will build a launch configuration, which is an AWS artifact that can provide files at the start of your instance. And we use a tool that we developed that basically builds that launch configuration with the encrypted secrets in it, and it will be unciphered on the instance at runtime. We are going into using a Vault-like system because we believe that this is the next step into security that we need to take. But this is the system that we've been building on, and it has worked very well. We believe we have reached the point where we need to go into a more efficient, more secure system.
Okay, thank you.
You're welcome. All right, thank you very much.